So, guys, we're going to talk about combination. Okay. Combination is connected to counting principle and permutation. In the last video, we talked about permutation. We're going to talk about combination. Okay. So, let me grab a slide first. Okay. So, let me see. Give me 1 second. All right. So, guys, I'm not going to jump to combination yet. I'm going to give you a little overview of what we have done in the past. And I'm going to start with permutation. So, permutation is about arrangement. Okay. Order matters. For instance, you want to arrange 5 books in a row. How many ways you can do it? You want to arrange 5 people on 5 chairs or 3 chairs, how many ways you can do it. It is really a special case of counting principle. What is counting principle? Counting principle is simply if you can do task A in 5 ways, task B in 6 ways, you can do A and then B in 5 times 6, 30 ways. So in combination, order doesn't matter. I'm going to start with an example. Okay. I'm going to start with an example and I'm going to connect it to the permutation formula as well. So you will see how combination is related to permutation. So this is combination. Let's write it down somewhere. We're talking about combination. Okay, the word combination in English is not directly related to the word combination in math, okay? So it has a very specific meaning. So I have a group of 3 people and they're A, B, C, Andy, Bob, and Carl. How many 2-member committees can be formed? So I'm going to do it from scratch. So let's say I have 3 students, they're A, B, and C. I'm going to send only 2 to a conference in Atlanta. How many ways can I do it? In this case, the order doesn't matter. As long as A and B are going, it's same as B and A are going. Order doesn't matter. So how many ways can I choose 2 people from here to go to the conference? Well, I'm going to list them all for now. Let's say I want to send A. I can send A with B and A with C. Okay. So at least 2. Then let's say how many other, I'm now I'm going to say how many ways B can go to the conference. Of course, B can go with A, but that's listed above. I don't have to relist it. So the first I ask how many ways I can send A. The answer is 2. It can go with B, it can go with C. Then I ask how many ways can I send B? Of course, that's 2 ways, BA, BC, but BA is already here because the order doesn't matter, so only BC. How many ways can I send C? Of course, 2 ways, CA and CV, they're both listed here. So I can send a 2-member committee in 3 different ways. Okay, we write combination as follows. See, how many people? 3. How many? What's the size? How many people am I sending? 2. Now, this is formula that's very nice, that very nicely connects to the permutation formula. So you write this 3 comma 2, and then you have to just divide it by 2 factorial. That's the formula for combination. I'm going to tell you why the formula makes sense in a second, okay? So if I say this is n, this is r, this is n, this is r, and this is n factorial. Sorry, r factorial. Okay, the reason the formula makes sense is you can just, this is the reason why the formula makes sense. You can just pretend order matters arbitrarily. So sending A and B is different from sending B and A. Then the question becomes a permutation question. Okay, basically you're asking how many ways you can arrange the 3 people in a line, taking 2 at a time, A, B, B, A, A, C, C, A, B, A, A, B, and all those things. So you're going to say, well, that's easy. That's a permutation question you're asking. You're going to say the answer is this. 3, comma 2, which we know is 3 factorial divided by, sorry, going back. So 3 comma 2, which we know from previous video is simply 3 factorial divided by 3 minus 2 factorial, which is 1, but we're going to write it here because it's not going to be always 1. Now, since the question is a combination question, the order doesn't matter. So A, B, B, A is the same. So since you are counting A, B, and B, A to be really the same group, you have to divide it by 2 factorial because 2 elements, 2 people can be arranged in 2 factorial ways. 3 people can be arranged in 3 factorial ways. So you have to divide it by 2 factorial. Further. Now this becomes your combination. I hope that makes sense. I'm going to do one more problem for you. Okay. And you're going to see it makes a lot of sense. If you have small numbers like 3 and 2, you can just do it by hand. But when you have 30 people and you're sending a group of 20 people, it's not feasible. It gets very messy. It can be done systematically, but it's very time consuming. So let me do one more problem. I'm going to do it from scratch. I have a group of 20 people. How many 10-member committees can be formed? Now, when I say committee or group, order doesn't matter. Okay, and you have to get that. I have a group of 20 people. How many 10-member committees can be formed? The answer is, well, it's a combination problem, and it's going to go like this, 20, comma 10, which is simply permutation 20, comma 10, but don't forget to divide by 10 factorial. 10 factorial. Now, permutation 20, comma 10 is simply 20 factorial divided by 20 minus 10 factorial. 10 factorial. And then don't forget the extra 10 factorial. And then your calculator will do it, right? But there's another better way of doing it. Most calculators, I'm using Desmos here. Most calculators will have a permutation combination buttons. Okay. So here, if you go to functions, you have. So this is NPR. We are writing it in a different format. So NPR is 20, comma, 10 plus. And then you have to divide it by 10 factorial. Function 10 factorial. That's your answer. And that's a pretty large number. Okay. And I'm going to show you, you get the same answer if you just hit 20, 20, comma, 10. You're going to get the same answer. So the permutation formula is related to the combination formula. Okay. And you can use your calculator to get the answer. So it's, let me write it down here. So think about doing it by hand from scratch. It'll take you forever and it's not feasible. Once again, to summarize, permutation is where array order matters. In combination, order doesn't matter. Okay, so this is a basic introduction to combination. All right. If you need help with problems from your book, just send me the numbers. I'll be happy to do them. Thank you.